Hi, Joseph. How are you?
I'm good. How are you?
Good, thank you. Do you have any questions before we start?
No, I'm good for right now.
Okay. Okay, so we'll wait a minute before we get started. Hopefully you will join us. All right, so we have about a minute if you want to check out your your assignment and your notes. This week we're going to cover array in Python, which is different to list. We're going to use Numpy. Okay, so I'll go ahead and get started. This week we're going to cover chapter 3. And we're going to look at array operations using pandas and NumPy. So these are the two primary libraries that we're going to use. Now, if you use Conda in the past, you might have installed Conda with pandas for a CIS30E or a class with Dr. Lair. You don't have to use Panda in this particular assignment. You can simply bring in the library to your IDE. So we'll touch on how to be able to install with or without Conda, and then how to be able to write programs working with arrays, multidimensional arrays, and then the methods from the library. So the Unit 4 notes here, you can find that it's going to start with NumPy. And this is just an extension to what you see with the Python package. We're able to use it for mathematical calculations. So in data science, or when you implement math in your algorithm, you want to consider using this particular module. So for your design, it is able to adapt the C arrays data structure. So in C++, you might have learned array, and we talked about how array would be used as a container. So in this week, we're going to distinguish between list and array. Now, if you want to know the installation, you can click this link here, and I should have that open here. So in their documentation, they give you the recommendation you can use it with Anaconda. And when you do that, you would need to use Conda and appropriate commands following Conda. Or another way that you can install, right, NumPy is to use pip. So we talked about using pip in the past with the other module. And you can go down and look at the installation information, alternative, and how that works with the Python package. So in the case where if you're using Python, I just want you to be, Conda, you should be aware that Conda, under its subdirectory, you're going to find the modules installed, versus if you're using pip, that will be installed directly to the subdirectory for Python package. Okay, so navigating to the location where it would be storing the actual module, making sure that you have the module, especially when you're using the virtual environment. So in this particular assignment, we don't need virtual environment. We can simply write it with our IDE and bring in the module into our IDE. So in the first part, it talks about using NumPy, how to install it. You simply can do that in command line, or in Windows, that will be your command prompt. Now, if you're using an IDE, last week we talked about how to bring that in via your package management on your IDE. So on the second page, it goes into array, and array is different than your list in that array is a container of, and it contains different elements, but the elements have to have the same data type. So if you're using integers, they all have to be integers. If you're using string, they all have to be strings. Compare that to a list, which we've learned previously for Python. It is a container, but in a list, the content of your list can be a mixed data type. So you can have integer, string, long, double, different types in a list. Now, when you create an array, what will happen is it's going to dedicate the storage to store the elements in a contiguous manner, very much like what you've seen in other programming languages like C++ or Java. So what we want is we want to be able to utilize this library or module and be able to create our array. Now, as you go a little further, it's going to talk about the D-type attributes. So what this does is it's going to take your data type and it's going to associate that with your array. So we can say that this is going to be 64-bit integers. All that does is in your storage, it's going to create appropriate allocation of the storage for the data or the content inside your array. And we can also convert it using AS type method. So if I'm working with integers and at one point I want to convert all my integers to have to become float or have decimal points and control the precisions for my decimal points, then what I can do is I can use a method or D type to be able to change my data type for my array to become a float like this. Okay. So you simply just specify the type, the data type that you want, because as you know, Python is not a strongly typed language. So when we create an array, whatever that you put inside it is what it's going to type as. But if you wanted to convert it to a specific type instead of parsing it, what you can do is you can specify the D type and then the type that you want. So in this case, we want a 32-bit float. So we would say D type is float 32. And remember that we need to put it in quotation marks. And in some cases, we might convert float to integer, and so on. So what that does is it changes how the storage is allocated. So we can go from a certain type and change it to another type. Okay. So now I'm going to come to your assignment. Let's come back to the beginning. And you don't have to put in the screen capture. I just did this so that way you can see the commands. So the first question asks, how do you install Numpy using conda and pip command in command line? So for conda, in the case that if you want to use the virtual environment or not, you simply use the conda command, and that would be conda install Numpy. Now, to follow that up with activating the virtual environment, it will be like this. So you cannot simply use conda without installing Anaconda, right? So if you have Anaconda, you will have to use conda command. The way that we have been using so far is to use pip, and you can use pip or pip3. So if I have two different versions of Python, as in 2.7 and 3x, I would specify pip3. But if I only have version 3 installed, then I would just use pip and it automatically recognizes. So it would be able to install the package that I need, right, to be able to use in my code. And you can refer to the first page of your notes for the answer for number 1. So conda install numpy or pip install numpy. Now, assuming that we have our Anaconda set up properly, and that can be challenging on its own. So I don't require Anaconda, but if you want to use it, you can. Just make sure that you look at the documentation. And there are times if you run into challenges, you can also refer to troubleshooting. Okay. Section of the documentation shows you how to troubleshoot. So for the next question, it asks you to write a script in Python that uses NumPy. And we would create an array, and we're going to have the array elements as 50, 60, 70, and 80. But we have to use the NumPy array method. So your program would start with the import statement. And when you import it, you can name it however you want, right? You can say import NumPy as NP, or you can say import NumPy as, the way I name it is NumP. And then I would define my array. So I would say new array. You can name your array anything you want. And we are going to use the NumPy method array. So whatever that you identify that library as, or the module as, you would bring that down and you would say, for in my case, it's numpy. So numpy.array. And in the parameter, you simply put in the values that you want to initialize for the array. And then after that, we simply print out our array. So put that into the IDE. It would look something like this. I have my import statement, my definition for my array. So I declare my array. And here I'm using the method that it's asked for, and make sure that this match with this. So if you name it NP here, it needs to be NP over here. And then the values that we have from the question, and then we simply print. So let me clear this. Now to bring in NumPy in your IDE, in this case, I'm using Tani. I would start with clicking Tools, Manage Package, and then I would search for it. And then so once I found it, I just click Install. Now, if you're using idle directly from the Python package, you can also do pip install if your Python is properly set up with the system path. It should be able to bring it in. Or if you're using VS Code, then you just got to make sure that your module is linked. So once I install that and I wrote my script, I can go ahead and run it. And so here it prints out the content of my array, 50, 60, 70, and 80. And so that's how you can create an array using NumPy and the NumPy array method. So pretty straightforward, really simple. This is a one-dimension array. And so when it did this, it automatically typed it for me. Okay. And then as it is a container, right, an array, we would then also use the square bracket. So the difference is that in a list, we said earlier that we can mix the type. In this one, we've got to make sure that all the data type needs to be the same. So if I convert this into a string like this, and I try to run it, right? It's gonna make all of these into string, you see? Because based on the way that this method is written from this module, they are all have to be the same data type. Okay. So if I remove this now, the quotation marks, and I run it again, it should give me all integers. Any question regarding number 2? So simply just 3 lines, right? We should be able to achieve our requirement for our exercise. And you can also refer to this, the example on page 2. Okay, so we're gonna go ahead and proceed. So we accomplished number 2. Now for number 3, we will continue it. So given the array in number 2, you already created an array. We now want to add in the ASType method. We can convert it from what originally just simple integer. We want to convert it into float, 32-bit. So the way I wrote it here is 2 ways. The requirement for the exercise only require me to use the ASType, but I want to show you that you can accomplish the same. So you can have dtype and you can specify your data type, or you can use ASType method to be able to pass your data type in its parameter. So coming back here, we would go to number 3. And so based on what I typed down in my answer, I actually added a couple of the print statements. So I'll change this. So you can see. So the second print, it's going to print our ASType. So if you write this based on the assignment, you simply just need to import, right? And then define your array, which you had from number 2, and then add the third line from number 2. So you can edit number 2 and just add another line. Make sure that you're using the same array name and then the ASType method. Okay. So the way I did it here is I used 2 ways. One is the dtype and the second is the ASType method. So let me clear this and I'm going to go ahead and run. So we're still going to be able to produce the same thing, right? Using the dtype or the ASType method. Now notice compared to number 2, here it's going to put your value with the decimal point. Okay. Because you're telling the system that this is a float, so it's going to include the decimal point. Any question? So for 3, we simply just add this line and make sure your array name is the same. And then a print line. And you should be good. So in this exercise, we see 2 approaches on how we can work with the data type inside our array. And on the same page that you see from the example, if you scroll down, it talks about that here. where you can use D type or you can use AS type. Now, for the next portion, we can touch on 2D arrays. So far, we've been working on one dimension. Now we're going to add another dimension. And similar to all the concept that you might have learned in programming classes about array. So the way that we separate one dimension from the next is to use the comma in between. So here's one dimension and the second dimension is following. Okay. Now we would enclose both of them by the square brace. And again, to create your array, we would use the array method, just like before. But in this one, we just have another dimension. So what that does is very similar to your two-dimensional list, right? But in this case, this is an array. We would then be able to have it like an X and Y, so it will be a table. So to access the element in the two-dimension, now we would use the index. But in this case, we have to specify which array and which index. So you have to use two things in the specification on which element you want to access, which array and which index. So this is the first array, array 0. And if I want to access the first element, that will be index 0. So 0, 0. If I want to access the first element of the second dimension in this array, I would say the second array, which is index using 1 for the second array, and then index 0, so 1, 0. Now you will see that in Numpy, later on, we can use our fancy indexing method or approach to be able to access the indices. So it allows us to access it a little bit differently compared to the traditional way that we simply use the index value in the square brace to represent the actual index. But you can do it that way as well. Okay. Now, we will also have an exercise with the axis. So in the two-dimension, for Numpy, what we can do is we can use the dimension as axis. Okay, so when it refers to axis with the Numpy jargon, so the jargon is that axis just represent the number of dimensions. So what we can do is when we look at this, an array would form like a table, as you know, right? So we can have 2 rows or 3 columns depending on the dimension. So the way that we can represent the dimension as axis, we can use the shape method. So when we use the shape attribute, what will happen is it's going to output your array dimension in a tuple like this. So if I have 2 rows and 3 columns in my array, and I use the attribute shape, it's gonna give me the dimension for that array in a tuple. And so what we can do is we can take, right, the dimension and we can reshape it. So it also allows you to use the method to assign the value and change up the shape or the axis of your array. So in this example here, there are 16 elements. And so we can do 2 by 8, 2 row, 8 columns, 4 by 4, 4 rows, 4 columns. Think of it like a table. Or we can also spread it out to more higher dimension. Okay. So if we're using shape, we simply would be able to output the tuple. Now, as you look at the example, what they did was they change up, right, the way how the array would look by using reshape. So I can take the 1-dimension array and then make it 4x4 or 2x8 for my 16 elements. And Numpy allows you to use these methods that were written in the library or the module in order to do that. Okay, so we're going to practice with the next ones in our exercise. So for number 4, we would start with creating 2-dimensional array. And the content is for the first dimension, we have 100, 200, 300. And then the second dimension, we would have 40, 50, and 60. And so we would start with making that the 2-dimensional array and display the content. And just like before, you would use the Numpy array method. So to be able to make your array, and you simply show how the content would be for your array. So let me bring you to my number 4. So we would start with the import statement. We're going to import numpy as, and you can name it anything you want there again. So in my case, it's numpy. And I would then declare my array. So here I have 2D array. And then whatever I name here, I want to use that down here with my array method. And then I specify the content in its parameter. Again, don't forget that it uses the double square bracket instead of a single because it's 2-dimension. So the inside, that's 1, right? This is the first one, comma, and then the second one. So we have to use a separator. And then after that, I simply print. So let's clear this and run. And there you have it. So for Python, if we do the print, right, it automatically access the elements and then print that out for you. So you don't have to use a for loop to access each of the indices at, the first dimension, the content of the first dimension, the content of the second dimension to print with the for loop. We can simply do that. Yes, you can use a for loop, but we can simply just do a print with the array name and that will work. Same thing with the list. So that's how we can create a 2-dimensional array. Fairly simple, pretty easy. Then what we're going to do is we are going to take that and we're going to shape it. So when you look at this, right, you have 3 elements in each of the dimension. So you wanted to see what that would be like as axis. Okay, so when you're using shape, we can output what that would be like as axis. So for number 5, what we can do is we can simply change up our print statement. And instead of just printing the array, you would then add the shape attribute. So if you do a dot shape in the parameter, So once you pass that, you should be able to print out the axis. So coming back here, looking at number 5. So simply modifying and adding this, and we're gonna go ahead and run. So here it tells me that it is 2 by 3. So as I have 2 dimension for my array, and in each of the sub array, I have 3 elements. So 2 by 3. And it shows that in tuple. But let's say that if I add in another element like this, right? And I run it again, right? It's going to tell me that for the object creating for the end array, it's nested in the sequence. It's not able. So what it does is it's going to tell me that, oh, it's not able to do the rest. So it's going to tell me that, yeah, there are 2 arrays, but I'm not able to give you the access for that, as the tuple is not changeable. Okay. So let's put this back to how it's supposed to be. So once I shape it, I cannot shape it again. I have to use reshape. So that's why it's throwing this. You see? It's able to produce this, but it's not able to shape the rest. So once I shape the axis, what I need to do is, if I want to change it, I have to reshape it, and that's what it's telling me here. Any question? Okay. So for our code, it's pretty straightforward. We modify that line, rerun it, screen capture it. So for the script questions, just make sure that you screen capture your code and output. Then moving on to the next part. You can see some example. You can specify the type as well if you want to change up the type. In the next example, you would see that they use random. And I think we touched on this during the first week when we looked at random, and when we did ran8, right? So at that time we were using random module, but with Numpy, you can also implement random. And this is often used, right, with Numpy. But you can definitely use the random module on its own. So what we can do is we can generate random numbers, and we can also use random ran to shape and return an array of random number for that shape, like this. So if I wanted to take a 3 by 3 array and I want to generate random number for a 3 by 3 array, it's going to do that for me. So you don't have, in the parameter here, you can specify its shape, but you have to use random.ran. So this will allow me to generate random number for that type of array. So using this module, you can also use 0 likes, empty likes, and 1 likes. So whatever your array is, right, we can pass it in here. So what I can do is, what if I want to change my data, all of the items to be all 0, or all of the items to be 1s? Okay. And then we'll take a look at the empty light. So what you can see is we can use these methods that were written for the library, and we can implement that in our program so we can quickly, because if you don't, right, you're going to end up having to loop through it and then convert the number or parse the number or change up the number. That takes too much work. So if I want to zero out everything, I can use zero like, or I can make it all in once. And so for the next question, okay, we are going to do an array that has 20 elements. We are going to generate or initialize them from 1 to 20. So they would be all contiguous. Then we're going to use the shape method and the reshape method. We covered that last. So once we have the shape, we have to reshape it, and we're going to make it into 4 by 5 because there's 20 elements. So 4 rows, 5 columns, and display. Okay. And then after that, we are going to do the 0 likes. So for 6, we just have to fulfill these tasks. Oh, somehow I didn't open my number 6. Oh, hold on 1 second. Now you can have it generated writing a for loop and then append the numbers to it. So I just manually did it so that way I didn't have to write additional lines, but you can definitely do that, right? Start with an empty array and then be able to generate it. Or we can do it like this. So we can have an array. We're using the array method from Numpy. So again, I have an import statement. Then I'm using the array method. Then I have my array elements initialized from 1 to 20. And then I want to print out its shape. Then I'm going to do a reshape. Okay. So as far as the exercise goes, this is as far as you need to go, is to do the reshape. But I added this particular section to show you. So what I did was I create another array called array new. And I want to store the reshape of the old array into array new. And I wanted to print it. To print the shape and to print the content. Okay. So we can run this program. So for the first print, when it printed the one-dimensional array from 1 to 20, it tells me that, yes, there are 20, right, in my one-dimensional array. It didn't really take on the full axis because I don't have more than 2 dimensions. So when you print the shape for that, you would often see that it's going to only show, right, the elements inside my one-dimension array, the number of elements that is, or my array size. Then after that, what I did was I made it reshape to 4 by 5. So here I would have 4 rows and 5 columns when I reshape. And as it is multi-dimension array, you would see that now it's going to output with the double square bracket. So once I did that, then for the next part, what I want to do is I want to take the reshaped array and then put it into another container called array new. And then print its shape. So it tells me that it is 4 by 5 for array new. Then I reprint the content. So ultimately it is still the same. It's just now identified in the second part here. It is identified as a new array new. So array new is now holding the reshape of the array 1. So using Numpy definitely allows you to create array and access the content of the array quicker. Okay. Then having to write loops or implement loops in your algorithm to access the content of especially the multidimensional array. So we can quickly find out how many dimensions, and so using shape, and then we can change up the dimension by using reshape. Any question? Now you have to think about like what's the number of elements in my array. And so when you shape it, right, to start, it's going to say, oh, only 20 elements. But when I reshape it to multi-dimension here, there's thought going into that, right? I cannot do a 4 by 4 because 4 by 4, what am I going to do with the rest of the elements? Or how am I going to make it fit? So as it is 20 elements, we're going to do a 4 by 5, or you can do a 5 by 4. You can also do a 2 by 10 because 2 times 10 is 20, right? So as it would be spreading across the columns and the row that you can make it fit. Okay. Any question? Okay, so that would be for 6. And 6 would just come up to there. You don't have to do the rest. This is just to show you how you can move that into another array. Okay, any question? All right, so now we're gonna do the 0 likes, the 1 likes, and the empty likes, which is the next question. So for 7, it asks you to write a Python script. First, we're gonna create a 4 by 4 array. And in this one, we can use random to generate numbers, okay? Because it didn't give us any value. So first we can do all zeros. So we can use numpy zeros method. So it's all going to fill in your 4 by 4 array with all zeros. Then after that, we're going to make an array that is 4 by 5. And these are going to be floats. So we are going to use numEmpty. And then after that, the third step is to do a 4 by 4 array. It needs to contain the floating points, and they are all 1s. So we're going to use the 1s. Okay. So in this one, we're going to use zeros, empty ones, and not the ones like the zero like. And then on the last step of the exercise, we're going to do a 4x4 array, and we're going to randomize the floating points. We're going to use random ran to be able to generate the random values in floats, and we're going to fit them in 4x4 array. Okay, so let's look at 7. So let me clear this, and I'm going to go ahead and move this down a tiny bit. Okay, you can just simply use Numpy. I had the second import statement here. So just like before, we have the Numpy statement for the import. Then I pass everything inside the print function or the print method. So for my first print, I would say print array using zeros methods. And here you would say Numpy, which is what I named here. And I'm using the 0 method. But inside it, you got to make sure that you put the axis 4x4. That was step A. Then for step B, I want to use the empty method. So again, I'm going to do a print, and then I added some strings so I know that, so I can differentiate the print. And I'm going to use the empty attributes here. And again, I'm going to pass my axis or the array dimension 4x5. For C, we have to use ones, and we want to specify the data type, because if you don't convert it, if you don't do the D type here, it would only give you integer as ones in the content of the 4x4 array. So again, I do a print method. I wanted to put some strings so I can see the difference on my output. And I would use ones. And in its parameter, I'm going to put the axis for 4x4. So, but I also added the D type. So here I want to make it into floats, 32-bit. And then lastly, we are going to randomly generate. So we just do a print, and we're going to use random ran, and we're going to use the axis as its parameter. So as we output here, it's going to give me zeros. Okay. So Python would automatically assume that zeros is going to be trailing some decimal, right? So it puts the float. Unless you want to make sure that it's just going to contain 0 without the decimal point, then you need to specify the D type. So we can make it int 64 or int 32. But by default, you would see this. Okay. Then for the next one, I'm going to use the empty. So in the empty, I wanted to do 4x5. So here it creates this. Now, these are not numerical values, right? They are locations for your values to go in. So what I did was I created a multi-dimensional array And as I made it output or print, it's going to show the addresses associated with these elements, locations for my multi-dimensional array. Okay. So it looks like numbers, but it's not, right? Because we told it to use empty. Then for the next step, I'm using ones for the 4x4, and I wanted to make it float, so it gives me 1 point. Okay. So I got 1, 2, 3, 4 dimension. 4x4. Now on the last step, we make it generate random values. So what we did here was we used random rand for the 4x4. So it's going to plug in the random values. Now you can control the data type that you want it to output, right? Like I can make it into whole numbers by doing integers with the D type. Or, if you want to force it to be a certain precision point, you can. But we just want to generate random values, so it's going to plug in all of these values here. And so it's pretty simple, 4 lines, right? We simply use the axis in the method parameters, and then we import in Numpy at the top. And that's it. Any question? So for future quiz and exam, right, we want to make sure that we know how to do this. You might get questions related to this for this particular module. All right, I'm going to go ahead and clear this. And we'll talk about the next set of methods for the next exercise. So for 8, we are going to create an array. Our array contains 10, 20, 30, 40, 50. Then we're going to do 0 like, 1's like, and empty like. So you can see the difference between number 8 and number 7. Okay. So here is my number 8. I have the import statement just like the other ones. I declare my array. So here I call it array2. And I use array method from Numpy to create my array, initialize the elements as 10, 20, 30, 40, and 50. After that, I simply do a print. So to distinguish, I added some strings. So using 0 likes. So here we put in the method 0_like, and then we pass the array name. So the array is in the parameter here. Same thing with the 1's like and the empty like. Now on the 0 like, unlike 0's method, you get the whole integer. You get 0, not 0.0. So earlier you saw in number 7, when you use 0's method, it gives you the 0 point. In 0 like, we're able to get 0. No point. Same thing with the 1's like. So when you do the 1's like, it fills in all the 1's. So it takes these values and change them to 0, and then we did the ones like for 1. And then for the empty like, it's still going to give me the ones as it previously used. Okay. So you have to think about data. When data is deleted or removed, so when we delete our files and folders, it actually doesn't really remove from the storage. Eventually, your storage will become available, right? It goes into Slack, and then that allows that storage to be reused. So when we say empty like, it's still showing the same content as last because that was what was used in the array. Okay. But that space will eventually become available for additional data, or I should say different data. Okay. So coming back here, okay, it shows that you can simply write the method using Numpy. And if you want to expand it a little further, you can also refer to the documentation. But as you can see, if you use empty or empty like that, just refer to the location where the data is or was. Any question? Okay, so that's what you see with some of the common methods from Numpy module. Now we will talk about access and how we use indices. So as you've seen in lists, you can use index to be able, index value to be able to access, individual element or a group of element on your list by looping through. So if I simply want to access the first element, I can simply use the index value and be able to find it, right? And be able to output it. Or I can implement a loop. So I can say for A in A, which is my array. So I can access the index and loop through each index in my array to be able to output. Python is a little bit more convenient in that if we print the array, it gives us the content of that array. Same thing with the list. We can print the array with its index to see that element value. We can have multi-dimensional array like this and be able to access the elements in the multi-dimensional array. So here you see the example, they're using a 3x3, okay? And when they access the index 0, it's gonna show the first dimension, which is 0, 1, and 2. So when you're using the index, the first index is gonna be the array dimension. The second index is gonna be the element location. Okay. So then we can specify the index and the the array dimension and the index value by using a separator or a comma. So when you're using multi-dimension, you gotta include, right, the tuple inside the square bracket like this. So you can say, I'm gonna access the 0 or the first array and this index location. So it's gonna point here, which is 1. So you can see various examples. Now you can also use the colon to be able to access the range. So if you want to go and find the first 2 elements, you can say 0 to 2. Why can't I say 0 to 1? Because it has to access the 0 index, the 1 index, and it's going to stop at 2. Okay. So we can use the colon with the indices. Any question? So this technique, you would see that they call this slicing, and you can slice string this way. You can slice like a group of values this way. And that's common in Python. Okay, so let's do some practice so you can see. All right, so for number 9, we are going to create a 3x3 array. We're going to use the for loop to access the content. So I want to make sure that you know how to write the loop for it, even though we can simply use other ways in Python, of course. Then after that, we're going to use the index to access the third subarray and display its content. So we simply put the index value for the third that represents the third subarray, because it's 3x3. Then we're going to slice the first to the 2-dimension array. So we're going to slice it and make it just the first and the second and display the content. And then the last part is to make an array that contains 6 elements. We're going to slice it down to 3 elements using indices and display the content. Okay, so we're going to do array slicing now. Let me move this up a little. That's clear. Okay, not too hard, right? It is a little longer than the others. So we have the import statement. We are going to create the 3x3. So I have here, I call it array 3. And I use array method and I initialize the value. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or if you want to be fancy, you can, because it didn't give you the values, you can do random if you want. Okay. Then part of my exercise, I have to do another array. So that has 6 elements for the later step. So I put it on top because, you know, by practice, we want to define our container at the beginning. So for my array 4, this is for step D. okay? And that would be the 6th element. So I just simply give them values, or you can use random if you want. Then the next part, I'm going to loop through the 3 by 3. So here I would say using for loop, I would have for I in array 3, and it's simply going to loop through and access each of the index, the index, and it's going to be able to print. Now, another way that we can do this, we can use the axis to be able to create the array, and then simply pass the array when we implement the loop. Okay, so here we have the loop, and we put it inside a container because as it loops through, it needs to be able to store those values and then print. Then for the next part, I'm going to go ahead and use the axis. So remember that we need to slice it to the first 2. So in this one, I would do a print and some string to indicate the difference. Then my array 3, I would then specify my axis. So at this point, it will be a 0 to 2. Now, on the next step, I'm using the index. So unlike the next part, which is slicing, I'm accessing 0 and 2. Okay, to show you the difference. So when we run this, so when I had it go through the loop, as you can see here, okay, this is the part we're covering. It shows me the subarray. Okay. Then after that, I'm using the axis. So if I say the first dimension and the 3rd element, which is 3. So it's the first array, the 3rd element, right? Index 2, it's going to give me a 3. Now, instead of using the axis, I can use the index, and the only difference is that we're using the square bracket for the second one when we're using the index. So I'm accessing the first subarray and the 3rd element, and again, it's going to give me a 3. Now we're going to do a slice. So I wanted to slice it where it would just be these 2. Okay. So what I have is I'm going to do a print, and to specify that I'm slicing in string. And then for my slice, I can say that it's going to go from 0 to 2 and 0 to 2. So it's going to give me 1, 2, which are these. So the first 2 elements of the first subarray, we can slice it like that. The start and the end. So we'll be here. Any question with those steps? Oh, I forgot to mention that it also had this 4 to 5. Just saw that on the next line. So 1 to 2 for the first part, and then on the next one, 4 to 5. So you got 1, 2, 4, 5. It's going to cut out the third column, which is 3 and 6. So this is the slice 2D. Then for the next part, what we're going to do is we are going to slice it down to 3 elements for the array 4, right? That has 6. So we're going to cut it in half. Recall that here's my array with 6 elements. So now I wanted to keep 3. So to print that, what I did was instead of using the print method directly, you will find that sometimes when you do that, it's going to lose the value because it has to return and then pass it into the next one. So it's better to create a container. So what I did was I define S array for slice array, and then I cut it. So it's going to be 0 to 3. And then I simply print out the S array. You can nest it into the print method, but when you nest it so many times, as sometimes it overwrite the value to that location, it might not be able to produce accurate or even any value. So it's probably better to create a container and then go to that container to retrieve, especially when you're working with container inside container. So it's when you nest so many things, sometimes that creates a problem. And I find that happens in Python periodically. So this is why I had created another storage space and then put in my slice only and then print it. Then what if I want to change the first element to 10, right? I can simply use the index value to update and reassign it for the update. So to update value of the element, you simply put the index of that element and then reassign the value. And so when I print that, I have 10, 200, 300. Any question? No question, pretty easy. So you getting this? All right. So array slicing, some example with that. And here it talks a little bit about side effects. And as you develop program, you write program, you will find sometimes you might have some side effects. So they put a note that to really prevent side effects, we can set the flags to false for the debugging process. So that way, in case, it mutate, that won't happen. So this is just additional information for you to use in case you want to apply that. Okay. So with this, we learn how to use the array with axis. We learn how to slice the array, multidimensional array. We were able to update values and we learn how to loop through it. And then, so now we're going to get into the fancy indexing. So like before, what we have is we're using index, but in this one, what we can do is we, instead of using individual value or having to slice it, we can specify a group of values or the group of elements that we want to pull from that array. And Numpy will let you do that. So if I wanted to pull 3 elements from the first position, the third position, and the fourth position, I can simply pass that, right? Using the array method. And so then after that, I will just print it out. So you put it into a container and then print out that container because you're accessing multiple values. So it's ideal that you put it in a container. Otherwise, you would have to loop through, or you would have to use individual index. So the way that we did this is we group up the indices called fancy indexing, and we pull those values and put it into a container and then print the content of that container. And so you can do it for multiple. So here you see that we can do it multiple times and then be able to output. And when you do that, it would just be a list. So it would put the value into your container and then we can output it. Okay. So we don't have to pull sequential value because when you loop, you have to iterate through each subsequent values. This way you can pull specific ones and you can skip some in between and be able to output. So it's definitely a faster way. Instead of writing, multiple lines, I can hit it all in one line. Okay, so you would use the inside of this, we would have a list. All right, any question? Okay, so for 10, we're gonna do another one here. We're gonna do mostly like hands-on coding today for our chapter. For 10, we are going to create an array. Its shape is 3, 4, 6. And it contains randomized value. Then we're going to make a second array. Its shape is 3, 6. And with Numpy, we can use what's called a broadcast feature. And what we're going to do is we're going to take the content and we're going to multiply both of the array to increase the dimension, okay, for the second array. So basically, you're taking the first array, you multiply it with the second array, and doing that, you elevate the dimension for the second array. And so then we have to talk about broadcast. Okay, so more example for slicing. And so broadcast is on page 11. So it treats the arrays with different shapes using arithmetic operations. Like if you think about like how you build out the matrix, right? In order to use one matrix with another matrix, you would then take the content of the matrix and then you would apply that to the second matrix. So it changes the output, the result with the second matrix, similar to that concept. So basically, you want to reshape the array by adding, subtracting, multiplying using the broadcasting approach. Now, it's ideal that you do this on the smaller scale, because if you have a very large array, the operation can take time and resources. Okay. So what this does is it's going to vectorize the array. And if you're familiar with vector in C++, right? Basically, that's a container. It is dynamically allocating. So that means that it shrinks and grows as needed. And as most of these modules are really C underneath, you can see that a lot of the approach is C-based. So what this allows us to do is we don't need to recreate the copies of it multiple times. We can simply implement the broadcast approach to be able to take the content and then apply it to another container and make that container grow. So here's the example. You have the A array, which has these values, 1.0, 2.0, 3.0. You have B array, which has 2.0, 2.0, and 2.0, and we want to multiply them, right? Because traditionally, we're going to have to use the index to access each of the container, get the value, take that value, and then multiply. Using Numpy, what you can do is if they are already in the array, you can operate the arithmetic. So if I take 2 times 1, I get a 2. 2 times 2, I get a 4. 2 times 3, I get a 6. Okay. So you can multiply the values. Now, when we work with the higher dimensions, right, we got to make sure that we apply the values accordingly. And using the library, it's going to allow us to do that. So in the next example here, I have the array A, 1.0, 2.0, 3.0, B is 2.0. So if we do it this way, we would still get the same result compared to this, right? So using the array or using the variable. Any question? So if you want to see more on broadcast, you can look at the documentation. I put a link for you there. And so now in scalar, this is how we're going to be able to apply for the multi-dimension. Okay. So if we apply the shape, what will happen is it's going to look at if I have a 2-dimension and I need to make it 3 by 2 and multiply it with 2, I have to scale it across. So what it will do is going to recopy, just like what you see up here. We took the 2 and recopy it and represent it so it scales to be equal in size as the other array. So when you have mismatch in size, the system, when you apply the operation, in this, like the example, we multiply. So basically it makes the copy, right, of the second array that is smaller and be able to apply the operation. So the example that they show here is you have A, right, and it's 5, 10, and 2. This is its axis. And B, you see that it has less. Okay. So when we multiply, right, it's going to have to do the scalar for B because B is less. So that means that it creates copy to scale out to the same size as this one so it can multiply. Any question? Okay, so that's what it would look like when it scale out. So using the library is definitely more convenient in that, you don't have to manually operate individual element multiplication. We use the technology to streamline the process, and ultimately it's that. Okay. So this is what we need to apply for our next exercise for 10. Let me see. I have 10 for fancy. So in 10, we call that we are going to do a 3, 4, 6 axis with randomized value, and then we're going to do another array with 3 by 6, and then we're going to broadcast. Okay. So I have import Numpy. My first array is array 5, and I generate random value for its axis. So here I just use a random ran. I imported random so I can use, but you can use it straightly from Numpy like we talked about before. For the second array, I call it array 6, and it's 3 by 6. So again, it's going to generate random numbers. And I wanted to broadcast now, so I wanted to multiply them. And just like the example, right, the syntax is you're going to use a colon, comma, and then you're going to use Numpy, which represents NumPy. And I would say new axis, comma, colon. Now I wanted to store it into array 7, so I can simply print it, right? So you can do the print right after each one. That's up to you, but I just do the print all at the end. So let me clear this. Let's pull this up a little. And then run. So my array 5, random numbers, okay? 3 by 4 by 6. And it goes further all the way to here. Then for my array 6, again, random numbers. I have 3 by 6, so a little less. Then I would do the multiplication, which I take 5, I multiply it by 6, and I store it in 7, which really represents the growth of 6. So this is the outcome. Okay. Now that reduced the operations in, to manually access the elements, copy the elements, and so on. So it's definitely just a one-liner, and we're able to achieve that. Any question for 10? So you can look at the example. It's pretty close to what I've used here. And it's fairly short program. So as this is smaller, right, than this, we would be able to broadcast and use scalar to be able to output in array 7 after we multiply. All right, so that's number 10. After you complete that, provide your script and your output screenshot. And then we just have to do one more. And we're going to use comparison next. So handling the data inside array as container using Numpy was the main target for this. And then also the text talk about pandas. So for the lab, I'm going to hit the pandas component as we do a lot of the work with the Numpy originally. So I like to cut it in half so that way it's digestible as you go through and you code your programs. So we would target most of the concept for Numpy. And then in the lab, we'll do pandas. Okay, so now let's move on to the next part. So on page 14 toward the end, you're going to see that it does have the sum capability where you can add up all the elements. Question. It's telling me that the operands could not be broadcasted together with shapes. So make sure it should be. Make sure that you have the syntax here accordingly. We're making the array 6 grow, so you can't reverse it. Okay, so you would do array 5 times array 6. And for the array 6, we would specify its content is going to be new axis. It's going to take that. So make sure that you have the commas in place. I put it into array 7. I don't know why it's giving you that error. Yeah, that will do it too, because if it doesn't separate, it's going to think that you're slicing it. And when using a colon, normally we use colon to slice things. And so if it's missing, if there's syntax error, it's going to operate differently, of course. Other questions before we move to the next one? Okay, so now, as I mentioned that you're able to find sum or total of all your element values. So it has the sum method. Okay, and we can do that. So here in this example, you can put in the axis and then it's going to be able to provide you the sum of each of the axes. But you have to initialize it like how they did it here. So ultimately, you're still going to have to initialize this because it's going to iterate through, right? Using the library, it iterates through and be able to add it up. So you want to specify your axis and then that way we can sum. Okay, so if I wanted to sum the first axis, the second axis, and so on, when you're using no argument, it's going to flatten it. It's going to sum everything. Okay, so that means it's going to take all the axes, it's going to sum it together, and it's going to produce an output there. Okay, so if you pass the parameter, what axis you want to use, then it's going to sum that particular axis. All right. So in the first one here, you see that we're using axis 0. So if you read that section, it tells you that the sum of the axis 0 produce an array shape 3 blank. The sum of the axis 1 produced an array shape of 5 blank, right? Because we specify the axis as 5 and 5 by 3. So if you say axis 0, it's going to say, oh, axis 0 refers to this. Axis 1 refers to 5. Okay. Then in the textbook, it talks about using norm. So you can use norm to calculate coordinates. And so in this one, the example you have norm is square root of x to the second plus y to the second. So we would be able to specify the coordinates of x and y. So just a brief section on norm. I don't think we have to use this, but for num expression, so here when you handle complex expressions, you can use num expression. Okay, this allows you to capitalize on CPU cache, which we covered last week. And so if you want to randomize numbers like what we did here, for Numpy num expression evaluate, this allows you to use the array expression for within the functions to operate whatever you want it to do. Okay, so I generate this number of random numbers, and the same thing for B and C. And then I wanted to add and multiply them, right? So these numbers are going to then be added and multiplied. So what that does is it's going to cache the values and be able to do the computation for you. Okay, definitely useful for the num expression. Now, it tells you here that it would increase the performance, so you can take advantage of it. And you can also use evaluate to evaluate your array expression and be able to handle the arithmetic operation for your container. Okay. And I put the link to the user guide so you can take a look at more example if you need. But this is one of the examples that I pulled from their documentation. Okay. And then, so we'll come back to pandas right after 11. All right, so 11, we're going to make an array with the shape 2 by 5. It's going to contain randomized value. We are going to use comparison operator to compare the element values to 0.7. So we wanted to check to see if is it greater than or less than 0.7. Okay. And then we want to display the values that are true based on the comparison. Then we're going to use the sum method to total the value of the first and the last axis. Okay, remember it's multi-dimensional, so we're going to do the first and the last. And then we're going to display the sum. So now we're going to take care of 11. So Numpy import, I have an array called array A, and it is going to contain random values. So I use random.ran, and it's 2 by 5. And I want to print the content to check. In my case, I wanted to check it to see if it's the values in the array, is it less than 0.7? Now, the cool thing about this is you don't have to add like nested if and all of that. You simply say array A less than 0.7. Right? We can skip the if, the condition that we need to set it. We can do it all in one statement here. It's still going to check for the criteria. So I wanted to print the values that are less than 0.7. You can do greater than, because it's randomized. We wanted to see which ones are less than a certain limit. Then I'm going to sum the first axis, which is 0, and the last, because it's 2, so 0 and 1. All right, let's run. So here's the content of my array after it generate the random numbers. Oh, no, this part. Then I wanted to find the values that are less than 0.7 using the comparison operator. You can do greater than if you wish. And then I wanted to print out the first axis and the last axis. Okay. Any question? So you should ask me, why do you use 0 and 1 here, right? As you see, it's 2 by 5. Think of this as an X and Y, right? This 0 is for X and this 0 is for Y. This is for my columns and this is for my row. So I wanted to see the values, right, in the columns and then for the row. Now, depending on the objective of what you're trying to do, in the case that if we want to do the sum that's less than 7, then we're going to have to put in the condition with the conditional statement, like if. But in this case, we just want to verify and pull. So definitely easy when you're trying to look for a certain type of certain data in the container, like if you're doing analysis. So you would be able to check, and Numpy is definitely helpful, especially when you work with numbers and mathematical operations. Okay, any question on 11? No question. Okay, so I would expect after this, right, we went through each line for our code. We looked at all the examples, the exercises in your assignment. also their example in the notes from the text. So you should be comfortable doing arrays, okay, using Numpy, and then using the common methods for Numpy. Okay, so we have a little bit of time left. Let's preview some information about Panda. And we're gonna implement Panda in our lab. So pandas is often used with NumPy. You might have seen or heard about this in prior class or through experience. And we want to use this for algorithm and data structure, which is the core of this class. How can we practice using NumPy and array? What you can do is, we will do more with the lab, with the pandas, but you can look at some example online, like for exercises and challenges. I know that there are tons of stuff, even through the documentation and tutorials, but not looking at the code, or you can go through the notes and not look at the example and be able to write your arrays based on what the criteria is. So when I write your assignments, I simply use the note as reference. And then for each of the section, I will come up with the exercise for you to do. But there are resources online that you can use. So you can think of like different dimension to work with. And then, you know, to be able to generate all ones, convert that into random, and then just redo some of our exercises, but using different dimension, that will probably help as well. So I would recommend that, okay? Or if you find data online, you can use those data, make an array that contains the data, and then try to see if you can operate something with the data. Like seek a certain type of data, like when we do the comparison. So there are many things that you can do, okay? But definitely practice. Okay. So as we talked about, Pandas, the tool regularly used with NumPy. Now, Panda, often you would see this in data analysis. So you would see that we can use it to create a data frame. So when you have a data, like, you know, from your CSV file that you see that you downloaded, or data from a database, those values are just raw data. You have to frame it. So when you frame it, what it does is, think of it like it puts it in a table, okay? If your data would require columns and rows, sometimes we would have column name. So in the past, you've seen how we can use Python to read CSV in our first week, right? When we pull data from online, whether you're using like data.gov or if you're using Kaggle to pull some fun data, you would see that, you know, the content of the file that you download, it would have columns that would indicate like what specific piece of that file means, okay? So for Panda, we can use it to frame your data. We can do a lot with the Panda to really create your data structure. And you can refer to the user guide. There's some good example there for you to use. So an example that I pull is from their documentation. So when you approach the data, right, we can create a frame. We can use series to generate series and print it. We can make a data frame that contains all random numbers, and we can also use what we learned today with NumPy with the axis. We can also create a dictionary, and in that we can apprehend the dictionary to represent the timestamps. Okay, so you can see some example there, and then with that, we can print out specific things on our data, like the column index, the bottom to the top rows, or top to bottom. So when you do a head method, it shows your data frame from top to bottom. When you do tail, it shows from bottom up. You can look at the index of the column, or if you print out columns, it's going to list all your column name. So definitely very useful, especially when you work with data from CSV or database file. Okay, so you bring it in, so you import that file in, let Python read it, and then convert it to data frame and be able to use it for different things. We can graph it. We can we can analyze a certain section or all of it, right? And we can build it into further, right? Like we can make it into, fit it into a certain model. So more of the advanced level, you can use your data in so many ways. We can look at to see like what kind of product sells the most for the supermarket, or applying different rules in data analysis, like association rules and so on. So things like in association rule, you can look at like one object associated with the next object, like people who buy eggs will buy cheese. Is that true, right, from that data set? So your data set is brought in and we need to frame. So using Panda is definitely useful for data analysis. Okay. All right. So that was just the last part on the Panda. You can read a little bit further in looking at Panda documentation. Okay, I'm gonna wrap up for the session. So as you have completed the exercises, screenshot, you can submit it today, and you can submit it on by Sunday. I will get your grade updated from last week assignment this week. Okay. A little bit tied up today. Usually I would get some of my grading done today, but I will work on it tomorrow and Thursday and Friday. So just to make sure that I'm on track. Okay, let me stop recording.